voltage gain. The voltage gain AV is equal to V naught by Vi. You know, voltage gain is output voltage by input voltage. Output voltage is V naught, input voltage is Vi. So where do I measure output voltage in my circuit? See the circuit and say, where am I measuring the output voltage? Output voltage is measured across what? Output voltage is measured across what?
RC, sir.
RC. So by Ohm's law, what is V naught? V naught equal to
I naught
V
into RC.
I naught into RC. But see how am I measuring V naught? V naught plus is on the upper side, minus is on the lower side. But usually when current is going to flow, the entering node is positive and leaving node is negative. So if you consider I naught plus minus is having polarity like this, but V naught you see plus minus having polarity like this. So V naught and this polarity is completely opposite this line. So I am not writing V naught equal to I naught into RC. I am writing V naught equal to minus I naught into RC. You should understand why this minus sign is coming, because of the flow of current in RC from top to bottom. It is flowing upwards. If you consider IL, then IL is flowing from top to bottom. So this will be plus, this will be minus. So V naught will be equal to IL into RC. If you consider I naught, V naught will be equal to minus I naught into RC. Is it clear? Why this minus sign is coming? Because my direction of measuring the voltage is going to be different. The direction of measuring the voltage is going to be different. And you can see the same current is I naught is going to come up and flow through here. So I naught and IC are same, and the same current is given the value HFV into IB. So I can write I naught equal to IC equal to HFV into IB. See, this is a single loop, right? So whatever current flowing through RC, it is same current which is going to flow into your transistor. So I naught, here the notation for current is I naught, but inside the transistor you call it as IC, which is equal to HFE into IB. So I can write I naught equal to IC equal to HFE into IB, or directly I can write I naught equal to HFE into IB. This is the second equation. So substitute this in this, you get V naught equal to minus HFV IB into RC. Minus HFV IB into RC. So I can now I can output voltage I got. See, the expression for voltage gain is AV equal to V naught by Vi. I got the expression for output voltage. Now I want the expression for input voltage. Okay, I want the expression for input voltage. So I want what is Vi equal to. See, in the initial thing itself, we have assumed that this RB value is very, very large. So I'm going to neglect that RB here. To assume RB is not here. So I can write only one resistance you have here, HIE, and current flowing to the resistance is IB, which is same as II. So I can write Vi equal to IB into HIE. Is it clear? See, when you want to find voltage gain, the formula for voltage gain is output voltage by input voltage. And output voltage I found out separately. Input voltage I have found out separately at the input side. I have to divide both. So output voltage is minus HFE IB into RC. Input voltage is IB into HIE. Cancel the IB. So you get the voltage gain as minus HFE into RC by HIE. Minus HFE into RC by HIE. And why we are getting this minus sign here? Can anybody say why is that minus sign coming for the voltage gain? Why we are getting the minus sign for the voltage gain? This is a very specific property for common emitter amplifier. You should have studied this in electron devices, right? In common emitter amplifier, the input and output are out of phase by 180 degrees. That 180 degrees out of phase will come as a minus sign in the answer. So see here, usually gain will always be positive. So you're thinking the minus sign, you should not think that the voltage gain is coming as negative, so it is going to be loss. No, it is still voltage gain only. This minus sign indicates that the input and output of the common emitter amplifier are out of phase by 180 degree. This is the expression for voltage gain AV. See here, the voltage gain depends on RC. So larger the value of RC, the voltage gain is going to be very good.